Okay, hello everyone. We should be live here now, although you people at home will be behind me by about 30 seconds. So, I'm Dr. Paoletti, and I'm going to do some introductions here, and then I'll let you meet everyone else who's going to be teaching the class. So, just a little bit about how we're doing things. First of all, I apologize for not posting on Piazza sooner to let people know that we were doing the noon lecture. To me, it was obvious because it was on the calendar, but I got to remember that you people are not used to the way we do things yet. So you've got to get used to those things. So we're going to look at a bunch of things later that we have resources available for you. But first, I'm going to switch my input over here to a Google Meet with the other instructors and let them introduce themselves. Okay, go ahead. Calendar.
Hi, I'm Professor Darden. I'm here with Dr. Paoletti. We've taught this course together for several years now. I look forward to having you here. We're going to do some switching with lectures, so we're going to do these in packs of 6. I think you get Dr. Paoletti first. After that, we'll rotate, and I'm in the 3rd run here, so I won't see you until after the midterm all over. I will be doing the midterm exam review and, of course, office hours all throughout. Oops. Seriously?
Okay. I think I'm next. Hi, I'm Hector Garcia. I have been teaching 281 for the past 2 years, and before then on and off. Love teaching this material, this course. Have been working with Marcus for the past 2 years. Looking forward to it. My topic will be all sorts of sorts. So I think I'm the second. So after Dr. P's 6 lecture run, or however many times it is, then I'll take over, followed by Marcus, and then I'll let Max introduce himself.
Hi, I'm Max Kurgius. You can just call me Max. This is my first time teaching EECS 281. I'm super excited to be doing this and getting up to speed on the course and how everything is done here. I'm going to be teaching, I'm actually after Hector. I'm not totally sure unless we change that. But I think I'm teaching strings and sequences, and then I think we've got some stuff about heaps and maybe trees.
Okay, so I should have control of the microphone now. Let me go back to my input.
Yeah, I said I was 3rd, I was 4th.
Okay,
I'm last.
So I've got a couple of things here in the slides, and then we'll look at a bunch of other resources today. And you're going to get used to seeing my kitchen here behind me. I've got a list of our staff here, and so if it doesn't say otherwise, these people are IAs. So we got a couple of students who are staff members who are GSIs, who are graduate students, and then we've got a lot of IAs listed, and then Michael Jackman, the last one, it says AG means the autograder machine. So he's taking care of keeping that running and maybe adding a few features to it, etc. The other staff member you might have seen already, PotatoBot, is an artificial intelligence. It's not great yet. And what it does is it monitors Piazza for things like posts that have already been answered. So the potato is of limited intelligence. So you may see suggestions like, hey, it looks like this has already been answered. Why don't you check out, at 200 and at 300? And you'll read at 200 and be like, oh, wow, that was spot on. That was exactly what I needed. Let's check at 300. Oh, that's not related at all. So the potato does have limited ability there, but it'll also do things like remind you to put your unique name in parentheses, like in post number 6 or at 6 on Piazza. And the reason we ask you to put your unique name on Piazza is that even if you're anonymous to other students, we can still see your unique name, and that makes it easy for us to find you on the autograder machine, which on the autograder, when we look up students, we look them up by unique name. So if we don't have that, sometimes it's hard to associate a unique name with with a student name. Sometimes easy, sometimes hard. So we've got our weekly schedule here, and we decided, and this is still, we can still change this if people really hate us, but we are planning on recording one lecture each day on Tuesday and Thursday. We didn't see any sense in like me recording 2 lectures in a row and Professor Darden recording 2 lectures in a row. We thought it would be better if we did 1 lecture and then spent more time on office hours, which is usually the biggest complaint we have in 281 is about the office hours wait times, which we've done lots of things to improve that, and we keep working on it. So our plan right now is to do 1 lecture live per day. It'll be recorded for people who can't see it live. It'll be there in the future. And then we've also got the spring semester. We already did this thing completely online during spring, so all those videos are there. Also, if you want to refer to those. The labs, so the Google Calendar on Canvas, our plan right now is to have 1 lab every day of the week at a different time each day, and we're going to try to schedule those times to meet as many people's ability to make it live as possible. And so we will have that done by the first time labs meet, which is a week from today. We never have labs the first week of classes, which normally encompasses the Monday holiday. Well, this year, the classes started the week before the Monday holiday. So next week, there'll be at least 4 lectures, Tuesday through Friday. We might do an extra one in there just so we have 5 that week also. And the office hours, I'll show you a bunch of things of how to find office hours and how to find that stuff. So actually, let me switch my input over here. Let me make sure I've got my screen ready. Let's see, where's my... Okay, there's my Google Chrome. Let's switch over to Chrome. And what we're going to do is look at the Canvas site here, and I'll show you some of the things on there. So when you go here, it starts out with a syllabus. We have one address that we use for everyone. This is to improve your chances of getting a response more quickly. There's times when my personal email gets 200 emails a day. And so we use an administrative account, and the only people who have access to this is the faculty and a very limited number of staff, like 2 staff members who are going to be helping with admin stuff. So you can read through this. It's got the lectures, the prerequisites, etc., grade scale. You can read through all that on your own. Other things on Canvas. Schedule of topics. This one is really important. Oh, a new tab. So this is our schedule of topics. If you're here, you already found, hey, you found the first link for the first video on the schedule of topics. So these are already linked in there for the whole semester. All the videos are created. And as I posted on Piazza, the reason these are not public is because once when we did this during the winter, like the first or second lecture in winter that we recorded on YouTube Live, it was public and we had trolls in the channel. And I was trying to do like graph theory, and I used an example of plane flights, and Hillary Clinton came online and told me that I shouldn't be using airline examples because there was a pandemic and people weren't traveling, and it wasn't really Hillary Clinton. But so we ended up having to ban a bunch of people, and it was just a pain for us. So now the video links will be unlisted. If you have the link, you can view it. If you don't have the link, you can't see it. Until after the lecture is over, I'll make it live. Then also, we are going to put copies of those videos on Canvas. I'll show you where in a minute. And then you've got it says lecture, which is the lecture number. Professor Darden just added an R here because lecturer didn't fit in there. So you can see DP is David Paoletti or Dr. Paoletti. My middle initial is R, so DRP is both my nickname and my initials. So I'm going to be doing the first 6 letters, and then Hector Garcia is doing the next 6. Max Krogius is doing the next 6 with a skip in there. Marcus is going to do the midterm lecture review, and then Marcus is doing 6 lectures, and I'm doing the final exam review. So you'll see me back again at the end. So you can see the topics here. There are readings here for C, refers to CLRS, Kornmeiser, Invest and Stein. We'll talk about the books in a little bit. And it's also got the Joe Sudas readings in there. And so that's that. Assignments, if you look at the assignments tab, it'll have dates. When everything is due has got a date in here. Grades, we're not going to look at that because that'll show people's unique names and stuff like that. Calendar is a link to a Google Calendar, which has everything related to 281 on it. So you can see we've got lecture now, we've got office hours. So if you see office hours with a PR, that means professor office hours. Excuse me. And then we've got those scheduled for Monday. Excuse me, next week we've got them for Monday. And then we've got Tuesday, Wednesday, Thursday. Usually Professor Darden adds some on Friday. And Professor Garcia and Krogius still have to add theirs in. So we're still figuring out finalizing schedules there. Files, you're going to be seeing this tab a lot. This is where things are, like the lecture slides. The exam practice will have some complete practice exams in there. Answers will auto-reveal after the midterm or final exam review lecture. Labs, so labs isn't populated much yet. You can see my view of it. We've got the 281 staff PDF. You can look at that. That's got pictures and a little info about all of the IAs and GSIs. And I guess I can delete the old ones now from spring and winter. And then Lab 1 will be public and viewable on about the first day of Lab 1. If you look at the projects folder, there's a makefile.txt, which is just a link to GitLab and where we have our master copy of our makefile. Canvas doesn't allow us to post links as a file. We can add it on the left, which is a pain because then we make too many of them, or we can put it in a text file. Project 0, which is ungraded, is already there, and there's already people submitting it. That's ungraded. It's just for you to practice using the makefile, using a new IDE possibly. And then Project 1, it says, hey, Project 1 is available after September 8th. That's a week from today. So a week from today, 12:01 a.m., this goes public. Let's see what else is in here. So we got projects, lectures, resources. I'm going to say this a bunch. In fact, I had someone in my comments once said, I hear Professor Paoletti say Canvas, files, resources, optimization tips in my sleep sometimes. So you're going to hear me say this a lot. Canvas, files, resources, optimization tips. This is something you should start looking at. You're not going to remember everything. You're not going to understand necessarily everything in there the first time you read it. But this is a lot of tips. 3 major sections of it are optimizing for time, optimizing for memory, and optimizing exam grades. Read the optimizing exam grades now because it'll tell you things to start doing now instead of waiting until the day before the exam to do. And the optimizing for time and memory will help you on the projects. Sample code is some large examples that are in there. And you can see there's some separate subfolders here, like there's some Visual Studio files, Visual Studio Code, Xcode files. We've got installing and using documents that our video, there's a video that I'm going to mention in a little bit, refers to. So what else is here? Piazza link, 281 YouTube link. Quizzes, we don't have any quizzes, but we can't change the name. This is what Canvas calls the tool that they have for like multiple choice questions and stuff like that. So you can see here we've got lab 1, 2, 3. Every lab will have a quiz. I put that in air quotes. Every quiz really is just like some multiple choice questions that go along with each lab. And there's also the exams will be on here. The old ones are hanging around there. Course Manager, that's us stuff. Office Hours Help Queue is a link to an external tool where you can sign up for individual help. AutoGrader 1 and 2. We have 2 AutoGrader machines, identical hardware. We expect you to self-load balance a little bit. So if you go to AutoGrader 1 and you see there's 20 people in the queue, maybe you should check AutoGrader 2 where there's 3 people in the queue. You'll get your results back a little bit sooner. Link to Gradescope, which there will be lab stuff and exam stuff there. Alternate exam request is a little outdated. This link, I left it there. We will still use it for things like, hey, I'm so sick I can't make it to the day of the exam. but we'll talk later about how we're going to do the exam. Teaching eval, that's later on, middle semester, end of semester. Media gallery, that's where I'm going to be putting copies of the lectures. So if you end up having trouble getting to YouTube, I will put copies of the videos in the media gallery on Canvas. Okay, so that's all that stuff. Let's go back to that stuff. All right, so we went through that. 281 crash course. So we've got this recorded from a previous semester. It's really well done. The thing to definitely fast forward is staff doing introductions, because we've got a fairly large number of different staff this semester. But there's stuff in there on Xcode. There's stuff on Visual Studio. Don't skip all of the stuff on the IDE you're not using, because some of the stuff on Visual Studio will be about setting up and using Visual Studio, and some of it will just be, hey, let's do some coding in Visual Studio that will be part of Project Zero, which, granted, it's ungraded, but it's good practice for you. We got our midterm and final dates in there, and the exam times will have at least 2 exam times, maybe 3. We did 3 in the winter, we did 2 in the spring, we'll see. But we will get either 2 of them 12 hours apart, or maybe a little bit better spread than that, so that no matter where you are in the world, there will be like normal waking hours when you can take the exam. And that's why we did that survey of where people are. So the 281 crash course, here's a list of the things that it covers in there. Syllabus, we already mentioned that, so look through the syllabus. Prerequisites, we do enforce the prereqs for 203 and 280. We generally do not let people in who are not who do not meet them. Grad students cannot sign up for 281. If you were taking this in the winter, there's a separate section called 403, EECS 403, that is grad students, and they would get graded on a separate exam curve, separate project curve, but they take the same lectures and do the same projects. They just have different grading. Preparedness self-survey, that's in the quizzes again. Let's put quotes around that on Canvas. It's not really a quiz. It's ungraded. It's just some questions from some 203 and 280 material. Suggested textbooks. These are not required, but they can be useful sometimes. The first one, Introduction to Algorithms by Corman, Leiserson, Rivest, and Stein, or as I said earlier, CLRS is the way people refer to this book. This is a good book to buy a copy of and keep it forever. My first edition of this book that I got as a student, I kept it up until I got the 3rd edition, and then I gave the first edition away to one of our GSIs for 281. Josutis is a book that's a reference to what's called the Standard Template Library, or STL. There's online versions of this, not online. There's online versions of the textbook available, but there's websites that are not Josutis that are just as good, and we're going to mention those later on. Policy on collaboration. So things you submit for projects. Everything you do for projects must be your own. Now, when we talk about labs, we'll talk about lab partners and stuff like that, but except for labs, what you submit has to be your own. And all work submitted for projects, I suppose we should put, hey, exams there. So labs, you can work with partners, but the projects and the exams you have to do on your own. If you are retaking 281, I'm sorry to hear that, but you do get to reuse all of your own code. If, however, you did a lab with someone else in the previous semester and you've got that stuff, I would say you shouldn't be having a lab partner this semester, because then you'd have 3 partners in the group, basically, which, we allow partners of size 2. And we do have ways to detect cheating. We do have tools that we use, and unfortunately, the computer science department sends more people to the Honor Council than the rest of the College of Engineering combined. And it's not because we have awful, terrible students. It's because we have really good tools for catching cheating. So don't show your project code to other people. Now, this is less of an issue when we're not in person. But in person, I would have people in office hours come up and ask me a question, and their friend is looking over their shoulder at their code. And I just feel like, should I just take their picture and send that to the Honor Council? Because as soon as you show someone else your code, they can't unsee the solution. And so you shouldn't be showing other people your code. Don't post code publicly on Piazza. We don't really want you to even post it privately on Piazza. We'd rather just look at the autograder. Don't share your test files. Submit your own test files. Ask us if you're in doubt. For example, something that doesn't fit in here that is fine for sharing. In previous semester, I had a person who wrote a program that generated random input files for Project 1. And they said, can I share this? I said, sure, share it with whoever you want. As long as it's random, as long as every time you run it, you get different input files. That means if you give it to someone else, they don't have the same input files as you. And the code is not the solution to the project. All it does is generate random input files. So the Honor Code, you can read the link on Canvas there, and it's on the engineering website. We do take it seriously. We do put submissions through that. We hate doing this. And when I was a grad student, when I was a PhD student, I taught a class. And my advisor, and a good name, my advisor, his real name is Dr. Doom. So Dr. Doom told me when I had students that were cheating, he said, you can do what some professors do, which is ignore it because there's less paperwork that day, or you can meet it head on. I said, well, one of the people who cheated is the son of someone else who's tenured in the department. He said, then if you're going to bring them up for cheating, make sure you do it every step of the way, do it properly. And I even got the department assistant chair to sit in on my meeting with them to make sure I did everything right. So if I'm going to turn in another professor's child for cheating, I'm going to turn in you for cheating. I don't like it. I hate the paperwork, but we'll do it if we have to. Is it okay to use other resources for learning things? Yes, for learning things, it's great. But you shouldn't be reading code from other sources because, again, you can't unsee that code once you've read it. And the beauty of this is we don't have to find the source that you used. As long as anyone else who did the project used the same source as you, we can catch you both at once. So getting help and contacting us, we've got the admin email address repeated here. We've got, if you've got things, and this one right here is actually slightly out of date. This is more of an in-person semester thing. So when we do office hours, what we've got is we've got a tool where people sign up for office hours. And the general format is for the staff, for the GSIs and IA office hours, you're going to get in the queue and you're going to post a link for your own personal meet, and they will join your meet. For the professor office hours, we tend to start, especially near the beginning of the project, one-on-many. We're going to be talking to everybody at once. And if you have individual questions, you can also make an individual entry in the office hours help queue there, post your own personal meet link, and one of the professors will join you there and answer questions there. If our office hours don't meet your time zone at all, though, then do this. Email us at EECS281admin, suggest a range of times that would work for you. And remember, we are all of the faculty are all on Ann Arbor time. So if you're going to suggest times, I'm up until like 2 a.m. every day anyway. So that's fine with me. But give us a window of times that will work for someone who's like living in Ann Arbor, like in the 9 a.m. to midnight, 9 a.m. to 2 a.m. Ann Arbor time would work great. We've also got some other references here, CPP reference and C++. This I would say either or. Look at both of them, figure out which one's format you like best and can use the most easily, and use one of those. Those are great references for the STL. So that's the two references I referred to. Instead of Joe Sudas, you can go to one of those two websites. They have the advantage that they have code editing windows where you can say, hey, let me edit this code and run it inside my browser. And obviously the textbook can't do that. Piazza, so obviously go to Piazza, ask questions there. Something I forgot to mention earlier on is if you've got questions now, you can type them into the chat channel. I'm not going to answer them, but we have some staff members, some of the I's and GSIs are going to be here every day monitoring the chat if you have questions. Sometimes there'll be one of the faculty will be there also. Other professors that you have might tell you there's no such thing as a stupid question. And stay with me to the end here. I feel differently about it. I feel there is an entire category of stupid questions. And those are the questions that you never get answered because you never asked them. That's the stupid questions, are the ones that you don't ask. The worst that we are going to say to you in 281 when you ask a question is, hey, that's off topic. That's politics. That's not what we're here for. Or, hey, that's going a little bit far afield. It's related to what we're doing, but it's not really on point for lecture today. Why don't you bring that to office hours? That is the worst that we are going to say to your questions. Either it's not computer science or come and talk to us individually about it. Other things, get them asked, get them answered. For questions that can be answered with, some text, type your question in the live chat window and we'll answer it. If it's more involved, bring it to Proffice hours, bring it to office hours. Put it on Piazza. On Piazza, you can choose to be anonymous to other students. You can't be anonymous to the faculty and the staff, but you can be anonymous to other students. And we suggest that you, if at all possible, if you're not talking real specific code stuff, make it public, and if you want, make it anonymous so that other people can see the answer. Remember, on Piazza, try to do a little bit of a search. Like we had, I will give an example, I will make one up. We had people asking about this test case, like CLMK2-1 or 2-L, something like that. And people kept asking about it on Piazza over and over and over again. Well, hey, if you just typed in CLM2K2 in there and in the search box on Piazza, you would have found that it's already answered. So you may get your answer more quickly if you look at and do a quick search first to see if it's already been answered. Okay, so when you come to office hours, come prepared with specific questions. Conceptual is fine, especially like I said, near the beginning of the project, we're going to be doing a lot of one-on-many time and saying, hey, you've started to read the project spec. What questions do you have? Or do people have questions about the lab? Do people have questions about the lecture? We're happy to answer them. When you're asking very code-specific ones, you want to know what works and what doesn't. You want to be submitting test files. Now, in 281, test files, and we're going to talk about this a little more, they are different from 280 test files. So start coming to office hours soon after the project is assigned. Get those questions asked and answered, those general questions, near the beginning. You don't want to wait until 2 days before it's due to be asking I just don't get what this project is about. That's a little too late. So come to the office hours early, get those general questions answered early. And even if you don't have questions yet, come to the one-on-many part, listen to other people's questions. They may ask a question that you didn't even realize you didn't quite understand yet. When you do the staff office hours, so the IA's, GSI's office hours, respect their availability. If they stay past when they said they were going to end, thank them when they help you. If they let you know that they've got to leave, it's because they have commitments and they've got to be successful students also. They've got an online lecture to go to. They've got online office hours to go to with their professor. So be respectful of them if they do have to leave. We'll talk about the test files in just a few minutes. So for the Proffice hours, I forgot to update this slide for physical time. So yeah, doors open. We're not going to be on campus there. So get rid of that one. We're not going to be there when the office doors open because we're not on campus. So the office hours queue, and this, I forgot to update this first line. We had problems in the past when it was physical. People would sign up when they were in the middle of a class on central campus, and they'd be the first person in the queue. So we can ignore that one. Sorry, I forgot to update that for no physical classes. So we're going to try to get through people quickly and move on to the next person, and hopefully I'd like to get back around and answer more questions from you again, rather than spend a half an hour on you and not get to 10 other people. Grading, so the labs are 20%, projects, 4 projects are 40%, the midterm and the final are 20% each, and what do you need to do to pass this class? So to pass this class, you need to do all of the following. You need to get greater than or equal to 50% on exams. Or I shouldn't say that. This is a slight misstatement. If you do these, you will pass. So if you get greater than or equal to 50% on exams and greater than or equal to 55% on the projects and greater than or equal to 75% on labs, you will pass no matter what happens. If the exam was too easy, that exam bar is not moving up. That was our fault. If the exams were too hard, this number might go down, and we will announce that. That's our fault also. I've learned from both good and bad professors how to be a professor. I had freshman chemistry lab 1. I got a C with, I believe it was a 93% in lab, because my lab instructor didn't know that when the semester ended, everybody was going on a bell curve. And so he was just kind of lackadaisical about grading. He was like, I think you got it. I don't think you quite got it. I'll take one off. I had people that I knew that had like an 88 who were not passing. And that was just ridiculous. We had no idea where we were. So you will always have a good idea where you are. After the midterm, we will send out an email to everyone with what score do we have recorded for every assignment. If the class was ending, what would your grade be right now? What is this bar after the midterm has gone by? What is that bar? You do have to do all of these though. So there's an example here. I ran the numbers. If you got 30% on projects, 100% on labs, and 90% on exams, that does not meet the projects bar of 55%. You are not passing. To put it bluntly, if you can't get 55% on our projects, I don't feel comfortable turning you loose on groups in a senior level class. So our labs generally have a median of over 90%. Our projects generally have a median of around 90%. So these are not completely unreasonable bars to ask you to meet. So the labs, there's 10 assigned labs. You can work with a partner. You will submit them. There's always some combination of where things will be submitted. So as you saw, there will always be a part on Canvas, the Canvas quizzes. There'll always be a Canvas quiz for some multiple choice or multiple selection questions. So there on the labs, there may be questions where there's more than, you have to check like 2 of them correctly or 3 of them correctly. On the exams, no. On the exams, there will be one and only one right answer. It might say all of the above, but it won't be like, hey, I've got to decide which 2 to pick not having any clue. So there's only one A, B, C, D, E for each exam question. So every lab will have a part on Gradescope also. So every lab will have a part on Gradescope, which will be some coding for that week. And we'll talk about each of these in a minute. Some of them will have an autograder portion also. Some of them will also have like surveys that you'll fill out, and if enough people fill out the survey, everybody gets credit for it. Now, the lab partners, you don't have to register them. There's no tool to register them, but you must submit every part individually. If you don't submit the Gradescope part or you don't submit the autograder part, you don't get credit for it. So you don't have to register your partners, but you do have to submit each part yourself for each lab. Now, every lab you may see where we refer to written problems in the labs. Pre-COVID, this was done on paper, and it was to get you ready for the exams, which were on paper. Now that we're doing classes remotely, the written problem will be on Gradescope, as will your coding questions for the exams will also be on Gradescope. So it'll get you practice either way, whether we are in person or electronically, it's going to help you get ready for the exams. The lab Gradescope portion, this written problem, is graded for effort. Basically, did you turn something in that is vaguely related to what we ask you to do, then you get points for it. The more effort you put into it, the more you'll get out of it. You can collaborate with one person per lab. You can submit exactly the same code for the lab as your partner, but you shouldn't have 3 partners for one lab. You could partner with person A for lab 1, person B for lab 2. The projects. So there's 4 projects. This is completely individual work. It will always be submitted to the autograder. It's usually about 2-ish to 3 weeks per project, and we have late days that you can use on the autograder. So the autograder has 2 late days per semester for everyone, and you can use them as you want. We want you to use late days on Project 0 just to see how the late day system works. After Project 0 is done, but before anything else that's real is due, I will refund everybody's 2 late days. So if you use late days on Project 2, do it. Just see how the late day system works. Now, however, those 2 late days are required for each day it is late. So if the project was due on Tuesday and today is Thursday, and you didn't submit Wednesday, you need to use 2 late days today. Why? Because you had 2 days to think about it. If we didn't do this, we'll do a what's called reductio ad absurdum, reduction to absurdity. Suppose at the end of the semester you said, hey, I've got a late day. I will use 1 late day to submit Project 1 65 days late. No, you've had 65 days to work on it and think about it. So the late days you could use 1 on Wednesday and 1 on Thursday, or you could use 2 on Thursday, but you can't use nothing on Wednesday and 1 on Thursday. Now the projects use C++ 17. We're using version 6.2.0 of GCC, which isn't fully C++ 17 compliant, but you shouldn't run anything that you will be using, that we're not teaching anything that's not going to be supported by GCC 6.2.0, which is on the autograder and it's on Cane. Now, I do recommend using another environment. I do recommend, if you're on a PC, using Visual Studio, or if you're on a Mac, using Xcode. But be aware that if you only compile in Visual Studio, when you submit to the autograder, it might fail to compile just because the compilers are slightly different. Like Xcode is a great example. On Xcode, I think you can get away with not including like string or some other files, and the autograder won't let you get away with that. So try submitting to Cane before you submit to the autograder. So the autograder checks for not just correctness, but also timing and memory usage. You will get immediately feedback for most of the test cases. Now, I try to say this very specifically. When I say test case, it's something that's on the autograder. It's already there. We created it. When I say test file, I mean the files that you submitted with your code to do testing. So you will get immediate feedback on most, like 3/4 or more of the test cases, you will get immediate feedback. There will be some that will be hidden that we will add at the end when we do final grading, but it will not be the hardest ones. The hardest ones will all be up there to begin with. The, hey, we created this one by hand to be tricky, all those will give to you up front. The ones that will be added in at the end will have been created by the same program that created most of the other test cases that you'll have already seen. When the project ends, excuse me, I have a cat tapping me. He wants attention. Okay, Spencer, how about if you sit on your own chair here? Come on. Sit. Good boy. All right, you hang out there. Okay, so when the project is done, when all possible late days have been used, we will do final grading and we will use the best submission up to that point. If there's a tie for best, we use most recent. The autograder FAQ and every project will tell you how to tell us, hey, I don't want you to use my best one, I want you to use the last one. Show cat? Okay, show cat. Come here, buddy. He's shy. He doesn't want to show you his face. Oh, great. He wants to sit on my shoulder. Yes, show cat's butt. Let's not do that. Come on, get down now. Yes, I saw the show cat thing on the I think it was a high school teacher. So anyway, every project and the autograder FAQ has a link to a Google form to tell us to use your last submit instead of your best. So before you ask for help, like if you want to ask for help on, hey, I don't understand the spec, great. Come in and ask us questions about the project spec. But if you've got questions about why your code is not working, you should be doing these first. So when you're asking for debugging help, like why does my program not get the right answer, you should be doing these things. You should be submitting to the autograder, including test files of your own. And the test files that you submit are actually input files. These are not code. These are not code, these are input files. And with each project, the input files will look different, but we'll give you examples. They will be on, like the Project Zero has sample input files already uploaded there. So a valid input file would look like that for Project Zero. Now, Project Zero, we don't have any points for test files. But for Project One, we will be giving points for test files. And what your test files are there for is two reasons. One, the big reason is to tell you if you get the wrong answer to your own test file. And the first such test file that the autograder encounters, it will give you our correct output and your output so that you can compare them. The other thing you should do before you ask for debugging help in office hours is everything that we gave you, run it. And run it using Valgrind. We'll show you in lab 1 or 2 how to use Valgrind. Try to find a test that's as small as possible that reveals your bug. It doesn't help much when you come to us and say, hey, you know that 10,000 line input file that you gave us? Yeah, I get that one wrong. Tell me why. That's kind of hard to debug for both us and you. You want to make a smaller test file that you get the wrong answer on. Now here's an example. This is a screenshot from obviously fall 15, but the autograder looks pretty similar today. What it shows you is I've got one, let's go from the top here. So it's got which project it is and the name of the project. It's got when it's due. It's got a how many submits you've used for today. It's got how many late days you have remaining. And like right now it says not usable because when I took this screenshot, I did it as a student, and B, the project was already like long past due. This was on like, October 30th or something. So the late days weren't usable. If you can already submit today, it'll say that. It'll say you can already submit today. And if you can use a late day, that'll be replaced with a link that will say, click here to use the late day. The browse button, you go select a file on your PC and rows down here. So we got a row of headers. First thing here, that's download. That's a download button. So if you break your laptop, lose the files, accidentally just make a mess of the code and not, wow, my newest code is worse than my old code, you can always go back to the autograder and download it. The timestamp here, and you'll hear me say timestamp, the timestamp is when we received it. It's like year, month, day, and then time of day. So this is like 2015, etc. So the timestamp, if you click on that, it'll show you some long feedback, and I'll show you that. I'm going to get a window here ready here while I'm talking. Forgot to get this one ready while I was talking. Okay, I'm going to switch window inputs over here. Okay, so here's me, and this is my staff view of it. So if you click on the timestamp, you'll see a bunch of stuff in here. Let me make this a little bigger so it shows up better. It's got a bunch of feedback. It's got some it says, hey, we ran this program. This program should work on Cane. It's like this command, you could copy and paste it to Cane. It says, I've got all expected files are found. Here's our build output of the make step. And then it shows you, hey, we're scoring your executable. For this test case, you passed it. This is how much time you took. After the slash is how much time you were allowed. And then this is how much memory you used, how much memory you were allowed, and how many points you got. Look at this carefully. There are places where you could use a library. It could say up here, hey, you used a library that you're not allowed to use. We're going to take 90% of your points away. So don't post on Piazza asking, hey, why did it say I passed, but I got, 0.2 here? I was under my memory. I was under time. Why did I get 0.2 here? Read the part here that says why. So a bunch of test cases, time and memory, and it runs them in order of shortest to longest. So like this one is 5 point some seconds out of 8 point something, 58, I think it's 58, 5.8 megabytes out of 6.9 megabytes memory used. And then you got your points there, scoring your student test files. It shows you all the test file names and what happened with them. I put some in here that were invalid just so I could make sure that all of my error messages said the right thing. So like this is project 1 stuff. So it said, hey, the file header said there would be 2 words, but there appears to be 4 words in the file. So it looks like your input was invalid. So it tells you if you found our bugs. So like this one found our bug number 1, 2, 4, 10, etc. What do the numbers mean? To you, nothing. What we did was we took a perfectly good solution and we added bugs to it. We did things like, what if someone were to put less than or equal here instead of less than? Or what if they just forgot this check for an invalid thing? So we took a perfectly good solution and we added some number of bugs. And it tells you up here. There are 19 bugs to find in our code. You need to find 7 bugs to start earning points, 16 out of those 19 to earn full points. So it'll tell you how many bugs you found, how many points. Then it'll say if you didn't leak any memory, you get points for that, and then you get a total at the bottom. So this is what you see when you click on the timestamp. Now then it'll show you the individual test cases, and here I'm going to switch back to the slides because mine, obviously I didn't make any mistakes in that code. So if it's red, it was wrong for some reason. And it's got a legend down here. It says like WA is a wrong answer. TLE is time limit exceeded. Like we cut you off because it was taking over 35 seconds. SIG is some type of signal. If you look inside the timestamp at that test case, it'll tell you what kind of signal you had. And it'll also, if it's a seg fault, the first one that you encounter, it'll give you Valgrind output and tell you what was happening in the code. Blue means it's bad in some way. Blue means overtime and or over memory. We tried making like five different colors. So like there was green and red, and then there was 3 other colors for like overtime, over memory, and overtime and over memory. And it got too confusing for me personally because I'm colorblind. And so this color scheme I can read clearly. So if you have a blue one, look in the timestamp and it'll tell you whether you're over time, over memory, or both. And the further you go over, the faster the points degrade. If you are trying to meet those requirements, we didn't make them completely unreasonable. What we did was we wrote a pretty straightforward solution. We avoided inefficiencies that were obvious. We did not take every optimization we could have. We just wrote a pretty straightforward solution the way we figure students would write it. Then the autograder runs that a bunch of times, averages the results, weights them towards the worst because they fluctuate a little bit as you run it, and then it multiplies the time by 1.5. So if ours took 8 seconds and you're at 12 seconds or under, you're at full points there. And if ours took like 10 seconds and you took 13.5, you're still fine. It's memory. If we took like 10 megabytes and you were at like 13.5 megabytes, you're still fine. We give you a 3/8 over on that, or 37.5% over on memory, you're still full points. There's some labs where it can be blue, but you're still getting full points because there was something that we thought was an obvious optimization, but maybe students didn't do it because there was a simple solution that was a lot easier and a lot shorter. So there's 1 or 2 labs where you can be blue and still get full points. Again, click on that timestamp, go all the way to the bottom and see, it'll say like 5 points out of 5 or 10 points out of 10, even though you might have a blue one in there. But on the projects, you want everything to be green, hopefully. The bugs caught. Start this early. Do not wait till the last minute. I've had students in the past, in office hours, say, hey, Dr. Paoletti, I've been working on this one test case that's over time all weekend. I just spent 3 days on this test case that's over time, trying to get this last 0.2 points on that over time. And I look at their autograder and their score is 89.8. And their bugs caught is 0 for every submission all weekend. And I say, wait, what about the test files? Oh, I'm going to do those later. And I look at the time and I say, the project's due in 7 hours. You've got 3 submissions left. You could have been finding those bugs in our code and getting those points every time you submit it. So if you're not submitting test files, you're kind of not using the full capabilities of a submission there. So don't wait until the last minute to find them. Some projects are easier to find bugs than others. We didn't write the hard bugs on purpose. We wrote bugs that were mistakes that were easy to make when we were solving the project. Mistakes that sometimes we missed when we wrote our first solution. Or sometimes we'd have like 2 or 3 staff members write a solution and one of them would say, oh yeah, I didn't get this thing when I wrote it. But then we compare them and make sure everybody agrees what the right answers are. But use those test file submits early. If you get it wrong, we will tell you. So for every test file, that's an input file, that you submit, what we do is we run our correct solution, which will reject yours if it violates the rules, like it's too big or does something wrong about the limits. Every project will say what your limits are, how big the test file can be. So if you do something invalid, we'll reject the test file outright. But otherwise, we'll find out what the correct answer is. Then we will run your solution, if you have one, and we'll get your answer. If those two differ, the first one we see will give you our answer and your answer. And then, regardless, we run it on all of our bugs individually. And if you make our output differ from our correct solution, you have found the bug. So that's how the test files work. Here's an example of a project. This is old, so this is first submit from September 2013. So this was the first semester I was here at U of M. We made this graph. So what this shows on the x-axis is when did people first submit their project 1, from the day the autograder opened until the day it was due. And it may be hard to see on the video, there are tiny little tick marks representing each hour of the day in there. So notice, most of the people who submitted in the first couple days, so the y-axis is their final score. This isn't their score the first day, but this is saying, hey, this person did a submission on the first day they could, and their final score was all in like the 95 to 100 range, except for that weirdo down there. I'm pretty sure that person dropped the class. They started early, but just never got it working and dropped the class. Compare that to people whose first submission was in the last couple of hours. Their score, you might have rolled a random number in the range of 1 to 100, and that was their score, or really 0 to 100. Or no, 0 to not quite 100. Nobody in the last couple hours here got 100. And you see this general trend of the people that submitted earlier tended to get higher scores by the time they were done with the project. People who waited until the last minute to submit didn't have as good an expectation of their final score. And I can reproduce this graph for any project one, any semester. Other projects tend to get a little bit better. But if you're saying to yourself, hey, I got 100 on all the projects in 280, I don't have to start these projects until the last minute. I'm fine starting in the last day. You're probably wrong. Probably. There are 1 or 2 students every semester who can do a project like that. But in 281, you're probably not that person, just because of the time and memory constraints. We've got projects that are easy to get right answers and hard to get under time and under memory without spending some time thinking about it. So the exams, we've got the exam dates there. Like we said, we're gonna figure out the time of those 2 or 3 times throughout the day for those exams. And the multiple choice, every student taking it will get different multiple choice questions. No matter if you're taking that, but the early exam, the late exam, doesn't matter, all random. And then the coding questions will be the same for everybody. Hey, what happens if you take it in the morning and you share it with just 1 or 2 friends who are taking it in the evening? Well, if they share it with 1 or 2 friends and they share it with 1 or 2 friends, that's what we call exponential growth. And then all of a sudden, everybody in the evening exam has seen the problems ahead of time, and I'm going to grade you all on the same curve. People ask us, well, why don't you grade the evening and the morning exam separately? I said, well, that would be helping the people who caused the problem. If I grade them on different scales, that helps people who caused the problem and doesn't encourage them to keep the question secret. If I grade them the same, that has a different effect. If I grade them the same, then, or if I grade them separately, then that helps the people that cheated to give them away. If I grade them the same, then that helps the people who cheated to receive them. I'd rather cut off the problem at the source and tell you I'm going to punish the people who give those questions away by grading you on the same scale. Now, if you cannot make that date at all, and we'll have like 2 weeks in advance, we will have the times of those. We got to figure out what our time zones are for the students, time zones for the staff and stuff, and we'll get those announced sometime in the next couple of weeks for the exams. And then if you're sick, if you cannot take it, then that's a last minute sort of thing. Email us at EECS281admin. Now, like I said, on curving, the exams we will change to make it easier to pass. We'll never make it harder to pass. We will lower that bar for what is going to guarantee you a pass, but we will never raise it. And then, like I said, we'll send out a mid-semester grade estimate. Will solutions be posted? Yes, for lab. Look on Canvas. No, for in-class exercises. For in-class exercises, sometimes. For projects, never. And for exams, we might outline like the midterm ones in lecture. If we had like people making common mistakes, we might talk about like a general form of the solution. For the lectures, I've got the first 3 on Canvas, and I'm going to get more posted soon. You can print them out or use digital ones. Taking notes, studies demonstrate time and time again, writing things down by hand. Now, I haven't seen a study writing things down tablet pencil versus paper and pencil, but physically writing is better than typing notes. Studies have shown writing things by hand makes a difference in long-term memory formation. So that will help you if you write things down. If you like print them out, if you can print them out and write on them physically, or if you've got a tablet that you can write on. If you don't have either of those, I would get some notes paper and write your additional notes by hand. Bring the notes up, read the lecture notes before lecture. Read them before lecture to prepare, know what we're going to talk about. You don't have to understand everything on every slide before the lecture starts, but you should know what we're going to be going through, what parts of the slides you do understand, what parts of the slides you don't understand, where, hey, I've got a question ready. If he doesn't answer this one during lecture, I'm going to be asking this question because I just don't get these, like from slide X to Y, I just don't quite get it. After lecture, go back over them. I used to do as a student. I would do later that night, I would go through all the notes I wrote that day and make sure I understood my own notes, like that they made sense, that I could look back at them and see what they meant before it became, 5 weeks later and it was midterm time. Now, some of the things that we do in lecture will not be in the slides. We might do an extra example on the tablet. I might write some code on the tablet. We might say, hey, let's create an extra question and run through this example together. So don't. If you can't view the lectures live as they are recorded, view them later that day. Don't wait until the exam and binge watch 281. Now, that's okay to re-watch them like the weekend before the exam, but don't make it your first watching of the videos is right before the exam. Get those questions answered early, like I said. So what do you need to do to succeed? Not just pass, but to succeed. Be organized. This class is going to be a high workload. That's how it's rated by students. And we know that. We put a lot of time on our end into making these slides good, improving them, making things make sense, having the labs lead you to the important things that you will need for the projects. We do a lot of work to help you, but it will be a lot of stuff, especially here at the beginning, things like the Canvas files, resources, optimization chips. I'm going to be saying that a lot. You're not going to understand everything in there to begin with. You're not going to understand everything about how you submit that project. I've already noticed people who they get a not available for all the test cases because they didn't tar up. They didn't make a tarball. They submitted a CPP file. So watch that video. Watch the crash course video that was linked earlier on. Watch that. Learn how to submit. Practice with Project Zero before we get to a real project. So we're going to provide lots of resources for you. Excuse me, I'm getting thirsty. Talking too much. We're going to provide you lots of resources, and we will try, I can't promise we'll succeed, but I will try not to get exasperated when I've said something 8 times and you still haven't seen why it's relevant or remembered that we said it. So it is a little exasperating sometimes when I get the same question 8 times in a row in office hours, and that's why we do the one-on-many office hours to answer those common questions. And I might say, hey, you joined office hours late, you've got a question. I say, you know what? I just answered that one 10 minutes ago, but that's okay. You weren't here at the beginning. I'll answer it again. I might say that, but I'm not upset about it. I'm still happy to do that example all over again. Allow sufficient time for this course. How much time is sufficient time? I don't know. That depends on you a little bit. Be proactive. Like I said, start the projects early. Start reading things. Start being ready for things. Don't wait until the last minute. Prioritize things. Don't get stuck too long before you ask for help. That's one of the things that you're going to learn about this class that's going to be different from other classes that you've had is you're going to have to ask for help more in this class than you have in the past. And that's okay. That's why we've got lots of staff and lots of office hours. They're not all official yet, but we're going to be adding 3 office hours per staff member per week. So we're going to get a lot of coverage there. Practice writing code by hand. If the only code that you are writing this semester is what's required for class, you're not writing enough code. If you've got a question like, hey, what if I did X with a vector? Write a little sample program. Go to CPP reference or C++.com, go to the vector page, go to their little inset editor compiler run window there and type the code in or do it inside of your IDE. Like in my Visual Studio, I've got a project called test. What's it got? It's got 28 or some absurd number of includes. Every include I've ever included is in there. And then I've got a main that I'm willing to throw away and replace with whatever I want to test. And so be willing to do those things yourself because you'll learn more by doing it. If you can't figure it out, bring it to us. We're happy to answer it. But do a little bit of work yourself first before you bring us that question. Computing Cares is a group within computer science, and they've got a website and they've got a video, which I'm going to switch inputs and microphone here to the desktop audio, and I'm going to play this video and then we'll come back and talk.
No, it does not deserve its reputation at all. I think it gets a bad rap because people like are complaining about it when they're taking it, but when you're like actually like looking back on it, I don't think it was nearly as bad as, you know, at least I didn't think it was as bad as people like made it sound, or as I thought it was when I was doing it in the moment.
So I guess it's a weeder in that if you have bad habits, like you'll get bad scores. But like all of my friends who all enjoy the course and study, like we do fine.
Like I feel like it does have that weeder aspect to it, but I don't think people should take it as seriously as everybody says it is.
Debugging, for sure, but that's always the most frustrating part and the most rewarding. One time I had a makefile that would not compile because I used spaces instead of tabs when I copied it over. It took me like a whole week to fix.
I wasn't ready for the time commitment with the projects, and I also wasn't ready to ask for help from other people. With project 1, I pretty much decided that I was just going to figure this out by myself, and after like a couple of those 10-hour sessions in Hatcher, I realized that wasn't going to happen. So I would say be comfortable with talking to like other instructors or things like that, because that's where I've learned the most. It's not by, I mean, a lot of the concepts in this class are pretty hard. It's fine to like ask for help from someone else. So.
I didn't do so well in the midterm, and then what happened eventually was that when we moved to new content, I really started to get it, and I was able really to understand it, which was really nice. And even though I didn't know it for the midterm, I knew it for the final.
Get something correct that I've been working on for a while. I think it's just very exhilarating to like type in, like go on diffchecker.com or whatever and put in the 2 outputs, and then it's like the 2 files are identical. It's very exhilarating.
One time I wrote code. It was like a pretty considerable amount of code, and it compiled on the first try. I mean, it didn't work. It didn't run correctly, but it compiled.
Oh my gosh. It was usually midnight. So I still lived in the dorms when I took 281, so there wasn't really much to go celebrate. But since Pizza House is open really late, I usually got feta bread.
I usually get a bag of Flamin' Hot Cheetos and just chill out with some Netflix.
The best meal is probably the Pizza House late night Cravers deal, because you get cheesy bread or like a personal pizza, whatever you want, plus a milkshake of any flavor. That's super good. No.
I had to devote a lot of time to this class, more than really any other class that I had this semester. But at the same time, I know I'll use the tools and things that I've learned in this class throughout the rest of my technical career.
I actually really enjoyed this class. So just like, I think a lot of people kind of dread this course in a lot of ways, but like you can learn a lot from this. And I think if you just tackle with the right attitude of just wanting to go to class like every day and learn, it's actually like really fun and you learn a lot. So.
I think I'm definitely happier now that it's been like a little while, because I think I've been able to use the stuff that I learned in that class and apply it into other classes, and kind of getting the chance to like create your own data structures and go about the process of starting a project from like start to finish in really like your own creative way. I think just really translated well into what I needed to do for other classes, especially upper levels in EECS. And so I think being able to apply it later on, I look back on it and I'm like really glad that that's what I got to do.
I feel like now that I've taken 281, I really know what computer science is. I feel like beforehand I didn't really know what was expected of me, and now I do.
Start earlier on the projects.
Just start the projects like right when they're assigned.
And go to office hours. Definitely go to office hours.
To not be afraid to ask questions.
Writing variables that make sense, and especially like writing functions so that when you analyze your code later, you can tell which parts are slowing down and which parts are fine.
Go to lecture, watch the lectures, at least that pertain to the things on the project.
Starting early has a lot of benefits, especially when you go to office hours. I know I've gone to office hours sometimes. I've been there for 3 hours. I move up like 2 spots, and it's frustrating. But if I start early, I only have to wait like 5 minutes.
I know everybody says start the projects early, but when they say start the projects early, they don't mean start coding day one. They mean like read the spec, figure out kind of like how you want to set up your classes and how you want to set up all of your code. That doesn't necessarily mean you need to start coding right away, but I feel like start the project early means have a sense of what you're going to be doing for the next 4 weeks.
Okay, I should be back here. All right, so those were students who took 281, and that video was not made by anyone involved in 281. That was the Computing Cares group, which you have the link here for their website. And how many hours per week? Like I said, it varies a bit per person on how comfortable you are with things and how well you plan and prepare things to begin with. Don't be afraid to rewrite some code. Sometimes you will write the project and have to rewrite part of it. The very first time I taught 281, I wrote project 1. I'm like, hey, I'm going to be teaching this. We're going to be releasing it soon. I should write a solution to this. And I wrote my solution, did pretty well, except it was over memory. And I was like, I'm the professor. I can't be over memory. Oh, yeah, that was dumb. Yep, that was dumb. So it was like 1:30 in the morning. And I'm like, well, no, I'm not going to bed until I get 100 on this. And so I had to rethink one of my data structures was just wasteful. And so I had to redo that data structure, had to change any of the code that referred to that data structure. And then after that, I got my points for my memory then. Study groups, so talking to people about what the project means. What it is you're supposed to be doing. Not what the code is going to look like, but what do you have to do? What's going to have to be in some data structures to be able to get this project done? Useful tools. Like I said, hey, leave that alone. Cat's chewing on my laptop cord. Okay, so automated compilations, makefiles. You're going to have to use makefiles this semester because the autograder requires it. But we've already got one for you. We've got a great makefile. It's really complicated. Our makefile, after you download it from Git, you can type in there, make help. And it'll tell you what it can do. And then we've also got the video that we linked earlier, the crash course, has a bunch of stuff in it about the makefile that Professor Darden talks about. And he's the ultimate expert since he created the makefile. Knowing an editor that you can use on a Unix system is a good long-term thing to be able to have that ability to use like Vim or Emacs, but much better is to use an IDE. So we'll talk about that in a minute. Having some sort of version control system like Git, and there's gitlab.umich, there's gitlab.eeks.umich.edu. Actually, gitlab.eeks existed before the .umich. We created it first, and then the university finally copied it and set up their own free GitLab server. But these have unlimited private repositories. They're maintained by the university. Just don't make your projects public. Now, suppose you don't do any of the things that we suggest. You don't upload to the autograder often. You don't upload to Kane to start testing with the same version of G++. You don't use a Git server. You don't copy them to a $3 flash drive and your computer dies. And then you look like that. And what's really amusing is the semester before I put this in him, that guy took 281 the semester before I put this in the video. So I have students every semester who say, my laptop died, I can't get it repaired for 3 days. The project is due. It's my only copy of the code, and I know my code works. I'm going to get 100. I just haven't uploaded it to the autograder yet. Well, like I said, chances are you're not going to get 100 on your first try uploading to the autograder. So make sure you don't have only one copy of your code. Make more than one copy somewhere. Get used to using an IDE. So an IDE, an integrated development environment, has one tool that lets you do text editing with the squiggly underline for errors, pop up for help for like, hey, what are the parameters to this function, advanced browsing where you can find, hey, my IDE has a function key, like if the cursor is currently on a function call, I can hit like F12 and it'll go to the code that makes up that function. And that can save you a lot of time. It does project management and debugging. It includes an interactive debugger. If you're using something like, I forget what people use. Sublime is a nice editor, but it's not an IDE. We recommend Visual Studio or Xcode if you're on a Mac. So here's a partial list of things that are IDEs. So we got Visual Studio, which is free for the Community Edition. The Enterprise Edition you can get through U of M, and I've got links to those. Xcode is free, so Visual Studio Community is free to anyone. Enterprise is free to students. You just have to create a Hotmail or an Outlook account to register it. Xcode is free to anyone with a Mac. There's other platforms that are free. These other platforms require you to get your own compiler separate from the IDE. Plotting tools, good thing to learn. GNUplot is great. It's a free tool. Excel is good. MATLAB is good. Google Sheets is good. So learning to use a plotting tool will help you in some point. This is sort of a breakdown of things in the class. We're going to be doing, before the midterm, more foundational stuff and building blocks, talking about time and measurement, etc., how to select algorithms for solving a problem. After the midterm, we're going to go to more sophisticated algorithms and data structures, binary search trees, hash tables, graph algorithms, algorithm families. 281, we can't cover every data structure. We can't cover every algorithm, but we cover a lot of the most important ones that make you interesting to a company for an internship. Interesting because you can produce code that they can keep. And so that's one of the things that, like we say, 281 is a heavy workload. We know it is. We put in a lot of work to make things flow for you. It is a lot of work on your part, but it's also going to help you in the long run. It is the class for getting internships. We're going to talk about data structures and abstract data types and how we have an abstract data type and we can make a data structure for some concrete implementation of it. Algorithm is a set of steps for solving problems. And we may go over a few minutes today to try to get nearer to the end of the slides. We might go over a little bit because I know you don't have to walk to another class very far. And we're going to talk about how to analyze things. So when we design an algorithm and a data structure, how long does it take? We'd like to be able to do some prediction on this before we write the code so that we don't spend too much time on a bad design. And that also when we do go wrong, we know where to look for what's causing us to go over time and or over memory. So for a given application, is it better to use algorithm A or B? Is it better to use data structure X or Y? And sometimes we can tell before writing code. Sometimes we can't. Sometimes the answer is surprising. And we try to give you some tips, like the project one is going to have a couple of documents. It'll have the project spec, it'll have some sample input files and correct output. It's going to have a tutorial for, it's called Project One, the STL and U. And there's going to be some resources that come out with Project One to help you get started. So we're going to do a little example here today. Suppose we wanted to do this. Suppose I wanted to write a function that takes in and out our arrays, and size tells me how many elements they both contain, and it says out sub I is equal to everything from the input except, notice, in sub I is not multiplied. Everything but that subscript gets multiplied. So for example, if I had in was 3, 1, 2, then my out should be 2, because this is the product of everything but the first one. 6, the product of everything except the 1. And 3, the product of everything except the 2. So that's what we want. So take a minute, think about writing a solution for this. And I'm going to show you 2 different solutions in a minute. I'm going to show you a straightforward one that's a bit slower, and a faster one that's a little bit trickier but has some problems. And I know you people have a 30-second lag on me. YouTube Live is not quite live. It's almost live. So I'll answer this one while you think about this. The Proffice hours is for projects. Okay, so let's look at 2 different solutions to this. If you're watching this later on, of course, you can pause this here. Even if you're watching it live, you can pause it for a minute to think about it some more if you want. So here's one solution that basically says, hey, let's run 2 for loops. Let's put a 1 in there, so out sub I gets a 1, and then we multiply everything that's not equal on the indices. So if it's not equaled, we do a multiplication. So we've got about O of n squared. This algorithm is about O of n squared to get this done. We're going to talk more about big O notation in the next couple lectures. So this one's about O of n squared. What if we wanted to do this a bit faster? Couldn't we go through, let's go back to here, couldn't I just, couldn't I figure out the product of all of them, 6, and then start dividing? I could do that. I could make 1 loop to calculate the product of everything, and then 1 loop to divide by the current element. So if I get the product 6, I could say, 6 divided by 3 is 2, 6 divided by 1 is 6, 6 divided by 2 is 3. So we could do that with 2 separate loops. So this one is about O of n. It's got n multiplications, it's got n divisions, but it also has bugs. It's got bugs if there's what? If there's zeros in it. What about if there's 1 0? What about if there's more than 1 0? So we can get an O of n solution that avoids the bugs, but we'd have to be a little bit more complicated. Maybe we could, before we do the dividing, maybe we could count up how many zeros there are. Maybe we could produce a product that's a product of things that are not zeros. So if I had a product of everything that's not 0, and I keep track of how many zeros there are, then I could change my division loop to get rid of those bugs. So I'll change my input loop to get to only produce the product of the non-zeros and keep track of how many zeros there are, and then I'll change my output loop to take those other statistics into account. So you can do a version of this on your own. We're not going to show you a better solution to this one. So the skills that you need to develop is, first of all, problem solving. That's what we do. Every day in computer science is problem solving. Sometimes we're solving computer science problems, sometimes we're solving other people's problems. So you'll get exposure as you get different jobs. You'll get exposure to other people's fields as you have to help solve their problems. Algorithm analysis, software development, practice, repetition, and rewriting. There's no way to avoid it. Every once in a while you write bad code that needs to be fixed. Memorization. And I don't mean rote memorization. I don't expect everybody to learn everything that's on cppreference.com. What I'm talking about here in memorization is Remember the most important things, and also know your own code. When you're writing code, know what your data structures are. Don't have to look at the code in a different file to know that you've got a structure with a string and an int and something else inside of it. So know your own code, know your own data structures as you're writing will help you save time. Being a good software engineer, when to know when different things are appropriate. Pointers or references. Pointers, Project 1, you don't need pointers. Don't use pointers in Project 1. If you're thinking pointers in Project 1, you're going the wrong way. It's a lot easier without them. Believe me, Project 2, you'll get enough pointers in there. Classes using the STL. Good code versus bad code. Good code is modular. It's not an 800-line main. It's concise and readable, and those two fight with each other a little bit. You know, I can have 21-letter variable names, but that's not very readable. I could have variable names that are 30 characters long, but that's not very concise. So we want to get to more of a happy median, like we had in the previous slide. I had a variable named product. Tells me what it is. It's not too long. It's only 7 letters. It makes it readable while not being too long. Debuggable. If you do all the other things, these 3 things help you with this. If your code is an 800-line main with 20 different one-letter variable names, it's not debuggable. Function robustness. Does this function assume that the inputs are right, or is this the function that validates the input? Know who validates input and know who doesn't have to validate it because it's already been done. If you reuse code, it's less work and less debugging. You'll find in Project 1, and I'll talk about this more in the future with Project 1 specific stuff, bad and good ways to write Project 1. And, oh, there we go. We're at the end now. Okay, so I'm going to finish up the live stream here, and then I'm going to head over to Profis Hours and meet people there. We're going to be knowing parts of the STL, and we're going to give you a file that tells you the parts of the STL that are most important to Project 1. The STL lecture is going to be more details that we don't need for Project 1, but more general stuff about how the STL works. But we don't need to know how it works to be able to use it.